So welcome to Electronics Excel. So we are in digital electronics lecture series. So today is the topic of discussion is the number system. Okay. So we will see in this lecture what is a number system. Then we will see some means types of number systems. Okay. Then we will discuss about the means radix of a number system. Okay. So what is a number system basically? So number system is a language of digital systems consisting of a set of symbols that is called the digits. Okay, it's obeys the rules for some well-defined rules that are addition, subtractions, multiplication, and other uh, mathematical operations. So what is the base of a number system? You can see in this case. So yeah, that is the it is written as 2. 2 means the binary number system is a base of means or radix of a 2. Similarly, octal, so it is the base of 8. Similarly, decimal, the base is 10. Hexadecimal, the base is 16. These are the common type of number systems. Okay. What does it signifies that the radix or base is the number of digits included in that number system. Like binary, so how many digits are we are having? So 0 and 1. So 2 digits we are in the binary number system. That is why the base is 2. Similarly, the base is 8 in case of a octal number system because we are using number of digits as 0 to 7. Likewise, we have decimal number system where the base is 10 and hexadecimal where the base is 16. So we will see the details okay in this lecture. Okay. So number system. So as I have told you, the number system is a language of digital system that consisting of set of symbols. The set of symbols is known as your digits. Okay. So the rules defined for mathematical operations such as addition and subtractions. Okay. And we have two broad categories of number system. Okay, so these are positional number system and non-positional number systems. So what is positional and what is non-positional number system, that we'll see. Okay, so positional means each position of the number is assigned some weights. Okay, a non-positional number system means we are not having any weights assigned to that particular number system. Okay. So in positional number system, each digit is I was talking about. So each digit has a positional weight that is determined by its locations. Okay, and positional means you can see the digit depends upon the both the digit and its positions. The digit value that depends upon the both the digit and its position, like binary, octal, decimal, hexadecimals. Okay, so you can see. So suppose some decimal number system, we're talking about some decimal number system. Suppose I'm talking about 1, 2, 3. So it is in decimal number system. So how it can be means obtained? So 1 at the base, this digit has the some weights. So this weight is your 10 to the power of 2. Similarly, that will be summed with 2 into the weights are 10 to the power 1. Weight of 2 is your 10. Okay. Similarly, 3 into 10 to the 0. So these are the called the weights of that number system because we are dealing with a decimal number system. So base is your 10. So that will be these are the each position has some weights. That this is the position of this the digit which the weights is your 10 to the power 0. This digit has the weight of 10 to the power 1. This digit has a weight of 10 to the power 0. Okay. So each position is having some weights. That is why it is the positional number system. So if it sum it here, it will be 100 plus 20 plus 3. That will be 123. Okay. So this is the decimal number system, and it is the comes under the positional number system. Similarly, binary, octal, hexadecimal, all the number system are comes under the positional number system. Okay. So next one is non-positional number system. Non-positional means the digit position does not determine a positional weights. So there is no weight assigned to each position of the digits. Okay, that is the like Roman numerals. This is the examples of the non-positional number system. Okay. So why the digital system are positional number system? Okay, because they provide the systematic representation and easy. Actually, we are doing some arithmetic manipulations. Okay, so that should be easier. Okay, that is why we are using the positional number system in digital systems. Okay. So basically we are dealing with the binary number systems in digital systems. Okay. Next one here. So Radix. So Radix, as I have told you, the number actually contains, there are two parts. One is the integer part, another one is the fractional part, separated by a Radix point, okay, or base point, okay. So you can see this is the number, okay. So it is separated by the Radix point. This is called the Radix point, and this part is known as your, the left hand side of the Radix point is your the integer part, okay. This is the integer part, and the, after this Radix point we have the fractional part, okay. So this number is consisting of, every number is consisting of two parts. One is the integer part, another one is a means fractional part that could be separated by some Radix point, okay. So what is MSD? You can see there is 2 points, MSD and LSD. MSD is the most significant digit, okay, and LSD is the least significant digit. So MSD, what we have in the MSD, you can see this is the called the MSD 8 n minus 1. This is called the MSD, most significant digit. So it is in the integer position. Similarly, LSD, you can see it is in the fractional position. This is the LSD. Okay, so this is the least significant digits. Okay. So MSD is the, as I have told you, so MSD is the most significant digit. It is a n minus 1. Okay. Next for the LSD is the least significant digit, which is the a minus m. So this is the least significant digits. It is in the fractional positions, and MSD it is a n minus 1, which is in the integer positions. Okay. So Radix wave, what is Radix or base? So it is the number of symbols used in that number system that must be greater than 1. Okay. So it is the number of symbols used. So some common positional number system you can see. So binary number system, what is the base? That is the 2. So number of symbols are used here 0 and 1. Okay. Similarly, ternary number system, the base is 3. So it is symbols are used from 0 to 2. Okay. Similarly, quaternary, the base is 4. So 0 to 3. Quinary, the base is 5. Then octal, we have this from 0 to 7. Decimal, as you know, it is from 0 to 9. Similarly, duodecimal, the base is here 12. In the duodecimal, the base is 12. And it is from 0 to 9. Then A, B. So 10 is written as A, 11 is B. The last one is your hexadecimal number system. Here the base is 16. So it is from 0 to 9, then A to F. So 0, A to F means it is 10, then 10, 11, 12 up to 15. Okay. So here the A is here, actually A is here 10. In decimal it is 10. Similarly B equal to 11. Okay. C 12 and D is your 13. Okay. Then E is your 14 and F is your 15. Okay. So these are the some positional, these are all the positional number systems. Okay. So these are all the positional number systems. Okay. So most probably we will be dealing with this binary number system. Okay. So this is very, very important. Then we are having the octal number system, decimal. Now these are the some means commonly used non-positional number systems. Okay. So next one is the decimal number system. So we will see what is decimal number system. So decimal number system, the base or radix of that number system is a 10. Okay. So here the symbols used, as I have told you, it is 0, 1, 2, 3, 4, then up to 9. Okay. So it is a position number system. Each position has some weights. Okay. So it is the integer and fractional parts that are separated by decimal. The radix point is known as your decimal point. Okay. So you can see this is the structure of the decimal number system. Okay. So this point is called the radix point. Okay, or decimal point. This is the decimal point, and this part is your it is the integer part. Okay, this part is your integer part. So this part is your after the decimal point, it is called the fractional part. Okay. So these are the weights. Actually, these are the weights assigned to that number system. Okay. So for example, as I have told you, so 472.515. So you have to express it like this. Okay. So this is called the sum of the digits. This express it in the sum of the digits. Okay. You can see sum of the digits. So express this one of the sum of the digits. Okay. So you will have 4 into, so what is the weight of 4? That will be 10 to the 2. Okay. So in the 7 into 10 to the power 1 plus 2 into 10 to the power 0. So this has the weight, you can see, this is the weight of 10 to the power 0. Okay. This is the weight of 10 to the power 1. This is the weight of 10 to the power 2. Similarly, after this point means decimal point, that will be 10 to the power minus 1. Likewise, it is 10 to the power minus 2. Okay. So if we sum it over, that will be your 472.58. Okay. So this is the means decimal number systems. Okay. So how to obtain that number? Okay. Using the weights. Okay. So key idea is that moving one position to the left, multiply the weights by 10. Okay. And moving the right, it will divide by 10. Okay. Similarly, we have the binary, that is the base of 2. So in the binary number system, the symbols use here 0 and 1. The weights are 2 to the 3 likewise. Okay. These are the after the this is called the binary point. Okay. After the binary point, the weights are this one. Okay. This is known as your binary point. Okay. Binary point. Because the base is here is your 2 and it is a binary number, so it is known as a binary point. Okay. So some common term are there. Bit we can name 1 bit, nibble is your 4 bit, byte is your 8 bits, similarly word is 16 bit, and double word is your 32 bits. Okay. So we have the octal number system which base is 8. So symbols used is 0 to 7. Here also it is separated. This point is known as a octal point. Okay, this is called octal point. So here means the weights are likewise. Okay, like that, means items after this point, that will be divided by is 8. Okay, so 8 to the minus 1, then 8 to the minus 2 likewise. Similarly, it is 8 to the 3, 2, 1 likewise. Okay, so each position has the power of 8 weight. Okay. The last one is the hexadecimal or base 16. So in this case, the symbols use are 0 to 9, then A to F. So as I have told you, this is A is your 10, B is your 11, C is your in decimal 12, D is your 13, E is your 14, and F is your 15. Okay. So these are the 10, 11. These are the decimal numbers. Okay. So weights are, you can see these are the weights. So here the base is your 16. Okay. And this point is known as your hexadecimal point. This point is called the hexadecimal point. Okay. So these are the weights, okay, of that hexadecimal number system. Okay. So let us summarize it. So number systems are used at digits. That is the we have some rules. Okay. So the symbols is known as the digits. Position number system assign a weight to the each digit according to the positions. Okay. And key bases are binary, that is base is 2, octal the base is 8, hexadecimal the base is 10, and hexadecimal the base is 16, and decimal the base is 10. Okay. Base is the number of symbols used in that number system. So let us have some practice questions. You will solve these questions. Okay. So this is assignment for you. You have to solve these problems. Okay. So determine the base. You need to find out the base of the number system. Okay. So this. So I am taking one only. So suppose 14 by 2 equal to 5. So how to find out the base of a number? So you know how to find out. So we don't know here the base. Okay. So let us take the base of the number. Suppose the base of the number system is R. Let us take that here. So according to the weights, so we can write here over here. Okay. So according to the weights, we can write word. So it will be 1 into what will be the weights of this one. So this will be R to the power of 1. Similarly, plus 4. Okay. So that would be equal to 5. Okay. So here we have taken the base is of R. So that will be 1 into R to the power 1. Okay. So in decimal, if it is a decimal, it will be 10 to the power 1. So we don't know what is the means base. So that is why I am writing is 10 is R. Okay. So that is R to the 1 plus 4. Divided by 2, that is it, divided by 2. So divided by 2 over here, that will be 5. Okay. So let us take that. So that will be R plus 4 equal to 10. Okay. So that the base of the number is R equal to 10 minus 4, that will be 6. Okay. So in this case, the base of the number is 6. Okay. Likewise, you can do this problems. Okay. So these are the assignments for you. Okay. So that's all. So thank you for watching this video. next class we will see some conversion of number systems. Okay, so thank you all and have a nice day.